shape side consists of 6 squares. Each of the 6 sides is 2 centimeters long. It can be folded to form a cube. Find the surface area of the cube. What does it mean by surface area? Sorry? It means like what is the area? So if you had a cube looks something like this. It means a cube is like a dice and there's 6 sides to it. You have to get the area of all 6 sides and add them together. So one side is 2 by 2. What's the area of 2 by 2? 4. So area of one side equals length multiplied by width, which equals 4. So that's 4, 4, 4, 4, 4, and 4. 6 times 4 gets you 24. 24 what? Squared, because it's area. Area is squared. Other stuff is cubed if it's volume. Is that the first question done?
Yeah.
Question 2 now?
Yeah.
Okay. Everybody take out your maths tables. Okay. Tin A has a radius of 3 centimeters and a height of 10.6. Okay. Find the volume of tin A and give your answers correct to the nearest whole number. What we have is we have the area equals 2 pi r h, and we have volume equals pi r squared h. What page is this on, Paul?
10.
Page 10. Which option should we take? Formula A or Formula B? V. Why? Because it says volume. Okay, so we're going to say volume equals pi multiplied by r squared, which is 3 squared multiplied by 10.6. Shift pi bracket 3 squared bracket 10.6. What we get is 299 points. Is it 70 or 71? 71. Okay. Correct to the nearest whole number. 300. And is it in centimeters cubed or centimeters squared? Cubed, because it's volume. Okay. Carton B has a square base. What does a square base mean? 5 and 5. Length and width are the same. What about the height? Oh, sorry, we don't know the height yet, do we? No. But what does it tell us? It has the same volume as carton A. How do you get the volume of a rectangular box? Length by width by height, which is 5 multiplied by 5 multiplied by h, because we don't know it. And we get 25h. Now, 25h, guys, has to be equal to what? Huh? Equals 300. Why does it equal 300? Okay. What's h on its own, Charlie? What would you do with the 25?
25 h equals
300 divided by
25.
25. And what do we get? Aaron? Paul? Anybody? 12. Did any of you get that on your own? Anybody in the class get that? Okay, guys. Now, which one of the above containers do you think the company might choose? Give a reason for your answer. Now, what do like stuff like cartons of milk and like tennis balls or containers usually come in? They usually come in a rectangular box. Would you agree with that? So if you imagine a rectangular box can be illustrated like this. It can be illustrated with a sort of like a parallelogram, can't it? And I can so you can draw it like this. That's actually not too bad. Everybody agree that's a well, it's meant to be a rectangular box. It's a bit slanty, but you get the gist, yeah? It's a rectangular box. Which is it easier to fit in? Which is more which is more compact? Fitting in cylinders or fitting in square boxes? Square boxes. So you can argue that the boxes will fit into a shipping container, like a larger box, more efficiently. There's no see the spare space you're not you see the space you're not actually using. While if you use a rectangular carton, there's no space in between them, which is a good thing. More compact. You also might say, is it a milk carton, is it?
Yeah.
You might argue a rounder milk carton might be more likely to fumble out of your hands, but just try and make some valid point on it. Is that okay?
So could A or B be the answer?
Yeah, I'd go for B. It fits into the large containers better. Okay? Difference between this. See all this space we're not using? Everybody see that? And then the other one is like this. There's no space you're not using. Okay? Now, these ones. Anybody remember how to do hours and minutes?
Yeah.
Okay. Mary needs to arrive in Heathrow at 10:30. What's the departure time that she can take the latest flight? 10:30, she has to be there for.
9:50.
Is she there for Heathrow for 10:30, yeah?
No, sorry.
10:15 is when she arrives in Heathrow, which means 8:50 kick off. Okay, 8:50 taking her flight. Find the time of her flight in hours and minutes. 10:15 minus 8:50. How do I do this, guys? It's not the metric system, it's done on a system of 60s. How do we do this? Borrow a 60. So we change 10 hours 15 minutes into 9 hours and 75 minutes. We take away 8:50 and we get 1 hour and 25. There's a button that does that in the calculator. Can anybody remember it? 10 hours 15 minutes take away 8 hours 50 minutes 1 hour 25 minutes. Is that alright? Two ways of doing it. Now, Mary would like to arrive in the airport 75 minutes before that flight leaves. At what time should she arrive at the airport? Well, her flight leaves at 8:50 and we're going to take away 75 minutes. How do we do that? Oh yeah, you can do it that way if you want. You can do it 8 hours 50 minutes minus 0 hours 75 minutes and you get 7:35. Another way of doing it would be just to turn 75 minutes into 1 hour and 15 minutes. Take away 50 minus 15 is 35. 7 hours 35 minutes. Everybody get that? Are we currently looking at it? Yeah, we got it. Okay. Next one's really easy, isn't it? You add up three numbers to get the total. So this total is derived from adding the blue 74.99, the green 25, and then the gap in the middle. Okay? So what we're going to get is 133.88, take away 25, take away 74.99, and what we get is €33.89. So that's questions 1, 2 and 3 done. Oh wait, no it's not.
Yeah.
Part C. Okay, distance. What's the formula for speed, guys? It's not in your notes. DST, isn't it? That's silly triangle. And you do speed equals distance over time. So you get rid of the S, and what you're left with is D over T for distance divided by time. The distance is 464. What is the time? The travel time. Was it 1 hour and 25 minutes or something?
Yeah.
Huh?
Yeah.
Why are they going all the way back there?
because that's the time it took to fly.
Yeah, but they kind of went to this.
Yeah, because you have to go, it's the same question, you just got to go back. Now guys, I'm about to make a mistake. Somebody tell me what mistake I'm about to make. 1 hour and 25 minutes.
Oh, you're not doing it in time.
This, see 1.25, yeah? That means 1 and 25 out of 100. We're using time. Time isn't out of 100. What is it out of? 60. So we should write this as 1 and 25 out of 60. Would you agree with that? Everybody right with that? 1 and 25 out of 60? Now you can do it like this. 464 divided by, now see this yellow button here? Shift, fact, you get yourself a mixed fraction. 1 and 25 out of 60. The answer should be 327.53. Does that have to round it up? So just, let's go for 327.53. Now, I can show you a different way of doing it. Something you might want to try out. 464, yeah? If you press this button here, and you divide it by 1 hour and 25 minutes, we'll see if it works. That also works. But, if I didn't have it like that, if I didn't have it like this, you should probably try and understand it anyway. But if I had it, okay, if I had 464 divided by 1 hour 25 minutes. Oh, it still works. If you use the hours and minutes button, you can do it that way as well. Okay. Everybody alright with that? We're not doing the mean. We're not doing 8. So I've done 1, 2 and 3, and now I'm on 9. Use a protractor to measure this angle. So you get your protractor out, you measure the angle, okay? You put it there and you measure. What do you get? What do you guys get? 50 degrees. Because it's an acute angle, you took 30. So around 50 degrees there. Even though it says 130, it's actually the 50 underneath it is what we're looking at. Okay, what about the next one?
115.
I got about 115ish. What you guys get? 115. One of them is an acute angle, which means it's got to be smaller than 90. The other one is an obtuse angle, it's got to be bigger than 90. Name the 4 angles. Start with the smallest to the biggest.
O, N,
O, N, and P. Okay, moving on. From the diagrams opposite, write down 3 angles together which add up to 180. Pick any 3 numbers that will add up to 180. Oh yeah, that's fair enough. Using the diagram on the right. From the diagram opposite, write 2 angles that will add up to give you 180. C and D, or D and C, because they are a straight angle which is 180 compared to 3 angles that add up to give you 180. What can you conclude from the relationship between angle D and angle A and B?
A and B equals D.
It does. A plus B plus C equals 180. D plus C equals 180. This means that A plus B must be the same number as D, because when you add them to C, they equal 180. Find the value of x in this diagram.
180 minus 68.
180 minus 112 gets me 68 in there. Everybody alright with that? And then what happens next?
D minus 68.
180 minus 68 minus 47, and what you get?
35.
75. Everybody cool with that? Okay. Question, I've done, what was it? 1, 2, 3, 9, 10, 11.
I haven't done 11.
Oh yeah. Okay, calculate the angle ACB. What type of triangle is this? Why is it isosceles?
Two sides are the same.
Okay, so what does this mean about this angle and this angle?
They're both the same.
They're both the same, so when you take 36 away from 180, then just half it.
180 minus 36 is 144. Half to 144. And you get 72 for both of them. On the diagram, construct the bisector of ABC. Show all constructions on the line. Okay. Anybody remember how to bisect an angle?
Compass.
With a compass. Which angle am I bisecting? A to B to C. Which one do we need to cut in half?
B.
Need to cut this one in half. Everybody right with that? Now how do I do this? Anybody remember? I get the compass, but what do I do with the compass?
Put the you put the dot on B.
Yeah.
And then
Pick a length.
Yeah. Above halfway.
Yeah, around that, yeah, doesn't matter.
And then you do
One.
oh yeah, it's
Mark both of them, yeah?
yeah.
Then what you do?
Then you go this way, you go that way.
You move it up,
Yeah.
and then we do this, because we're trying to bisect the angle. That means cut the angle in half.
Then go the other way.
Move it there,
Right there, you join.
and what happens next?
Then you do.
Where they join each other,
Yeah.
and you've cut that angle in half. Okay? Mark the point D where your bisector meets the line AC. Oh, I have to keep going, so. That is the point D. Calculate all the angles in the triangle BCD. Okay, this is 72. Would you agree with that? This angle here, guys?
Half a centimeter.
Half of 72, which is 36. And finally, the last angle.
Take away 36 and 72.
Take away 36, take away 72, and what do you get? 72. So it's actually another isosceles triangle. Yes, two angles are 72 degrees / same size. Measure AC and BC. What do you get when you measure the AC and BC? You're going to take out your comp. You're going to take out your. You're going to take out your ruler and measure them both. What do you get? 9 for AC and 6 for BC. Now, can somebody tell me something here? See the big triangle, yeah? Does anybody remember what similar triangles are? Anybody remember what similar triangles are?
Triangles that look the same but aren't exactly.
So, I could argue that, is everybody looking at this? Please pay attention really closely. I could argue that this triangle here, that I coloured in yellow, is a similar triangle to the one I'm about to colour in green. Why can I say that? They're exactly the same shape, aren't they? 72, 72 and 36. So, in a nutshell, what we're thinking is, sorry, that was 6, wasn't it? In a nutshell, what's going on is this, guys. We have a big triangle, the big one at the start. Everybody agree with that? Okay, and then we have a smaller triangle, like this one. And look what happens when I get the green one. I'm just going to move the green one out, okay?
Flip it over.
And I'm going to flip it over. Turn it upside down. And you notice that both triangles are the same. It should be a sausage triangle. So this one is 9 and 9. This one here is 6 and 6. What is the ratio of AC over BC? 9 over 6, which is 1.5 or 3 over 2. The triangle on the left is 1.5 times bigger than the triangle on the right. The green triangle was 1.5 times bigger than the yellow one I had earlier. Is that 13 I did?
That was 11.
Oh yeah, that was 11, was it? Okay. How much time do I have left?
8 minutes.
How much?
8 minutes.
8 minutes. Okay. You guys get on your calculators and call me out the answers. All you have to do is just type in sine 25 into your calculator. It's very easy. So basically, the first one's just sine 25 equals 0.4226. So, and how many decimal places? 3 decimal places. So 4, 2, 3. Okay, what you get for the next one? Sine 50 if you can. 0.76. Anything behind the 6? 6, 6. Cos 25?
0.906.
906. Cos 50?
0.6.
Get on the right page, guys. 0.643. Tan 25?
0.466.
0.466. Tan 50?
1.2.
1.2.
Yeah, it's 1.1912.
192. Ben saying? We'll check it out now.
After rounding it up.
7.
Yeah, tan 50. 17 rounds up to 2.
Okay.
So 192. Says 3 decimal places in the question, Charlie. Okay. Now, Marie said the value of all these trigonometric functions will always be less than 1. Was Maria correct?
No.
No, because this with
No, because one of them was over 1.
Tan is more than 1.
Yeah, tan 50 is more than just 1.19.
Oh, sorry, tan is 1.19. Sorry. Sorry, 1.19.
192.
192, sorry. No, reason? Tan 50 is bigger than 1. Okay, what's after that? Sharon said if the size of the angle is doubled, then the value of the function is doubled. So look, what happens when we take sine as an example? We doubled 25 to 50. Did the value double? Huh? No, it didn't. So the answer is no, as sine 50 is not double sine 25. Is that okay, guys? Okay. James said the value for all these trigonometric functions will increase with as the size of the angle increases. Is he correct? Well, look down here, guys. When it goes from sine 25 to sine 50, does it get bigger?
Yeah.
It goes from 0.4 to 0.7. From sine 25 to cos, from cos 25 to cos 50, does it get bigger or smaller? See the way it goes from 0.9 down to 0.6, so it gets smaller. So we're saying no, as cos 25 is a bigger number than cos 50. Everyone okay with that? Cos 25 bigger than cos 50. Am I missing a question here?
That's question 15.
Question 13. Do I have enough time? How much?
You got like 3 minutes left.
3 minutes?
Score.
Yeah, I have 14, 15 anyway. Okay.